Thank you for providing me a chance to explain our work in GNSS technology. My name is Takahiro Yamamoto. I'm a director of GNSS Solution Business Center at Core Corporation. Today, I'd like to talk about MADOCA receiver Kohaku Infinity 10 Plus and MADOCA drone solution. In the beginning of my presentation, I would like to introduce our company, Core Corporation. Core Corporation is an ICT company and was established back in 1969. The number of employees is 1568 in total, and we have 12 branches all over Japan. We provide ICT services including software and hardware for our customers. GNSS is one of our businesses and was started back 2005. The first QGIS satellite was launched in 2010, so our GNSS business has been advanced with QGIS evolution. We provide not only GNSS receivers, but GNSS solutions with application software. Here you can see the location map of our companies in Japan. We have 10 companies all over Japan, and the branches provide ICT service to our local customers. GNSS Solution Business Center is located in Kanagawa Prefecture near to Tokyo. Now coming towards today's agenda. Firstly, I'll make introduction of our QGIS receivers, Kohaku Infinity. Then, secondly, I'll describe our drone solution, Chronosky, using Kohaku Infinity receivers. Finally, I'll summarize my presentation. First, I'd like to introduce QGIS receivers Kohaku Infinity series. Kohaku stands for Kohaku High Accuracy Positioning Solution, and Infinity describes coordinates orbit of QGIS feature. QGIS provides two types of centimeter level positioning services, that is CLAS and MADOCA. CLAS can be used only in Japan, but the convergence time is short, less than 1 minute. MADOCA can be used in QGIS coverage area that is large as shown in table, but the convergence time is long, more than 15 minutes. So CLAS is almost used in Japan, and MADOCA is used in Asia and Oceania area. This figure shows QGIS schedule. The service started in 2018, and we Core Corporation provided several receivers. When QGIS service started, the receiver size was large, the weight was heavy, and the price was more than several million yen. This equals to several $10,000. But we released Kohaku Infinity 10 in February 2022 with improvement in all these constraints. Since that, our business is growing as use of the QGIS services has been made easy for many applications. We released CLAS and RTK receiver Kohaku Infinity 10 in February 2022. It has several attractive features. First, the receiver is smaller, lighter, and cheaper than the past receivers. Second, you can get your positioning information with 100 Hz. This feature is useful in high-speed mobiles like car and train. Third, it supports Wi-Fi and Bluetooth. That is why you can connect your device with the receiver easily. Fourth, we provide smartphone application for Kohaku Infinity 10. Therefore, user interface is very friendly compared with the command interface on PC. Fifth, the receiver has micro SD card slot. A user can log the positioning data without another device like PC. This is a demonstration of Kohaku Infinity 10. We improved the receiver usability by developing the smartphone application. A user can change the setting of the receiver and view their position with the smartphone. That is why the user can hold it and measure the position easily. The video here shows demonstration of our colleague walking along the line, and the positioning results are also seen in one line. The next is MADOCA receiver Kohaku Infinity 10 Plus. The signal specification of MADOCA was changed in September 2022. Our Kohaku Infinity 10 Plus is the first MADOCA receiver which supports the new MADOCA format. We demonstrated our new receiver at MGA Multi-GNSS Asia conference, which was held at Chiang Mai, Thailand on January 31st. The figure shows the positioning result by MADOCA. The center position is calculated by network RTK using Thailand core's continuous operating reference stations. As you can see, the accuracy is within less than 10 cm. MADOCA can be used for applications other than positioning. This is one of the examples. Our MADOCA receiver is used for the forecast of lengthy rain band. The lengthy rain band causes disasters like flood and landslip. Therefore, Japanese Meteorological Agency monitors the clouds with MADOCA receiver because MADOCA calculates tropospheric delay precisely. They equipped MADOCA receivers on their weather ships and monitor the clouds before they approach to the land of Japan. Up to here, I explained our QGSS receivers, but we don't consider our business domain is only receiver. Our focus is also in the solution. We will resolve our customers' problems by providing additional applications. One of our solutions is drone solution, ChronoSky. This slide shows our UAV lineup. The first one is ChronoSky PF2. We co-developed it with ACSL. ACSL is the biggest drone manufacturer in Japan. Since our receiver becomes smaller, lighter, and cheaper than before, we can equip it in the drone. CIRAS provides accurate position by itself and can be used without communication network infrastructure. The second one is RTK drone and our QGSS receiver, which is used as RTK base station. In this scenario, a user can utilize their existing RTK drone. The user can get the absolute position without mobile phone network and CORE's infrastructure. ChronoSky PF2 has several competitive features: high accurate positioning, network unrequired for precise positioning, secure and safe, and real-time video transfer. The picture shows precise takeoff and landing. ChronoSky PF2 land at almost the same place with takeoff. Therefore, you don't need a large area to use it. These are advantages of our ChronoSky. QGS CIRAS and MADOCA provide centimeter-level positioning only with satellite. That is why our drone realizes pinpoint flight. Also, accurate positioning enables to create 3D image without ground control point (GCP) described later. In the case of the standard GNSS positioning, GCP is recommended to use for acquiring 3D image accurately. But in the case of QGSS drone, a user can take pictures from high altitudes with drone for 3D image because drone position is very accurate. This leads to shorten the flight time and working hours of the operator. Lastly, QGSS drone doesn't require mobile network infrastructure for getting precise position. Therefore, it can be used even in uninhabited areas. This movie is a pinpoint flight demo by CIRAS drone. It takes off and heads for predefined waypoints. The marker is shown in the center of the movie. This indicates that the UAV realizes a highly precise position. Next is a drone for agriculture. This drone is developed by Toko Teko Company Limited. The drone equips our Shiras receiver inside. The drone flies autonomously and scatters the agrochemicals precisely. The next feature is no GCP. To create precise 3D data, a lot of operations are required in preparation phase, measurement phase, and calculation phase. To get precise 3D composite image, a user needs to locate GCPs and get overlapping pictures with the precise GCP locations. By using QGIS drone, we can eliminate the procedures related to GCPs. As a result, our solution reduces the operation time of UAV survey. This is an example of our actual customer project. Our customer planned to build a new bridge and wanted to monitor the status of their construction. Since QGIS drone doesn't require to locate and measure GCPs, they don't need to force users not to use the current road and can get the distance between the old bridge and the new bridge correctly without tough work. The movie shows 3D point cloud data of Japanese mine which was gotten by QGIS drone. Of course, the closer a drone flies to the object, the more precise 3D image a user can acquire. If a field is too large, taking pictures from low altitudes makes the operating time long. Centimeter level positioning enables to keep 3D data accurate by taking pictures from high altitudes. The feature shortens the flight time and operators' working hours. Our customer uses QGIS drone for calculating the mining amount for a certain period. Even though the field size is so large, our customer gets the mining volume within the weekend. They can avoid stopping the operation in weekdays. The last feature is network unrequired. CLAS and MADOCA calculates the precise position only with satellites. Therefore, 3D modeling can be used also in the out of range of mobile phone. This is an example of sound control dam inspection. In Japan, 70% of land area is mountains. Therefore, a lot of sound control dams are deep in the mountains to stop rivers and sediment. Our drone can keep precise position even in the out of range of mobile phone. So our customer can get the 3D data copy of the object without locating GCPs and visiting tough and dangerous places by themselves. In Japan, drone invisible flight in the manned area becomes possible in December 2022, so we expect that the drone use in the invisible situation will increase. I'm going to summarize my presentation. Today, I explained our QGIS receivers and drone solutions. We released Shiras receiver Kohaku Infinity 10 and MADOCA receiver Kohaku Infinity 10 Plus, which realized centimeter level positioning in 2022. We provide drone solutions because QGIS centimeter level receivers become smaller, lighter, and cheaper than before. Taking advantages of QGIS Shiras and MADOCA, Our drone solution is used in various kinds of fields such as agriculture, construction, mining, and inspection. Here I will finish my presentation. Thank you very much for your attention.